Now let us study a very important series in mathematics, which is the exponential series, and it is nothing but the expression for e raised to x, that is given by 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial and so on. So basically this series goes on for infinitely many terms, that is unending series. So based on this, suppose we want to find out what is the value of e, which is nothing but e raised to 1. So therefore we put x equal to 1 in the original series, and hence we get the value of e as 1 plus 1 upon 1 factorial plus 1 upon 2 factorial and so on. This value of e is basically between 2 and 3, so that's a number between 2 and 3, and its approximate value, suppose we want to see first few decimal digits, that is equal to 2.718 and so on. So basically it is an irrational number. It's a very important number in mathematics and calculus. Now let us move ahead and see some of the deductions based on this particular exponential series. Alright, so alright, so here are the deductions from exponential series. So for our reference, we have the exponential series written on the top. Now if we replace x with minus x in the original series, what happens is all the odd powers of x will become negative. So hence we get e raised to minus x as shown on the right hand side here. So that's the first deduction. Now if we add up the expressions for e raised to x and e raised to minus x, alright, so that is what is the second deduction. Now it is easy to see that the terms which are having odd powers of x, they will get cancelled because they are of opposite signs in both of these expressions. So therefore we will be left only with the even powers of x, correct? So therefore finally we have e raised to x plus e raised to minus x given by 2 into 1 plus x square upon 2 factorial plus x raised to 4 upon 4 factorial and so on. On the other hand, instead of adding, suppose we subtract e raised to minus x from e raised to x, then what happens is all the even powers of x will get cancelled and only odd powers will remain, and there will be a factor of 2, of course, because minus of minus is plus. So therefore here we get the third result. And last result is in terms of, say, instead of e raised to x, suppose we have some constant a raised to x. Now this we convert into the form of e raised to some function. So to do that, we can write any particular quantity a raised to x as e raised to log of that particular quantity. Alright, so we first write with this particular adjustment, and now we know that by the index law of logarithm, the x which is exponent will come down and it will multiply the log. So therefore we have further e raised to x log a. Alright, so that means finally we have e raised to some expression, and this can be expanded using the exponential series which we just saw. So wherever there is x, we will write x log a, correct, and hence we get the final expression as shown here. So that is how we use the standard exponential series to derive certain further extensions. Now let us solve one question based on this. Now here we have to find the coefficient of x raised to 6 in the series of e raised to 2x. Okay, so that means suppose we have to write the exponential series for e raised to 2x. Using the formula we have 1 plus, now in place of x we have to write 2x, so that will give us 2x upon 1 factorial plus we will have 2x the whole square upon 2 factorial and so on. And now we'll see that to get the term in x raised to 6, we have to go to the term where we are doing 2x whole raised to 6 divided by 6 factorial, right, and so on. The extension will of course go on forever, but this is the term which includes x raised to 6. So therefore this term is equal to 2 raised to 6 upon 6 factorial into x raised to 6. So therefore the coefficient is nothing but this particular quantity, and we know that 2 raised to 6 is nothing but 64 whole divided by 6 factorial. As we know from the definition of factorial, it is the product of 6 into 5 into 4 into 3 into 2 and of course into 1. So therefore here we can have 4 into 2 is 8. 8 will get cancelled with 64 with 8, and we can also cancel the factor of 2 to have 4 and 3 remaining. So therefore finally we have 4 divided by 45. So therefore the coefficient of x raised to 6 is 4 by 45, which is the answer.